which is at the end of our notes today. That's very easy. And then domain and range for a quadratic, okay? So I won't ask you a bunch of questions. You are specifically going to target those as we move forward after starting on Wednesday. Okay? So at the top of this piece of paper, here you have 2 blanks, okay, on the left side. So everybody know their left, hopefully. We're going to write the definition of a function, because everything that we put on the left side is going to be functions. So the definition of a function is a relation between 2 sets of numbers such that each x has exactly 1 y value. Now, I don't know about you, but sometimes when I do textbook definitions, they don't make a whole lot of sense until I look at examples. So that might not make a whole lot of sense, but when we start going through examples, hopefully it will make more sense, and then you'll understand why something is a function versus why something is not. Okay? Not a function, so on the top right-hand side, I'm going to put the definition of not a function. I should have wrote that bigger. Oh well. A relation is not a function if any x has more than 1 y value. I can. I'm going to just come out a little bit and move it like that. You're welcome. If you have a highlighter at your desk, I'm going to use a highlighter for a little bit. You don't have to have a highlighter. You can just circle it with your pencil or pen. That's fine. But some of you have them already at your desk, so I'm just giving you fair warning that I will be using it as we go through this. How many people have heard the term function, domain, and range before? At least one of those terms before. Okay, good. Okay, so everything on the left side will be functions. So we're going to look at the first one. And what you have here is 4 examples, each one slightly different. The first one will be just ordered pairs. The next one is in a table form. The next one's a graph. And the last one are just dots or ordered pairs on a graph. Okay, so I just want to give a bunch of different examples for that. Okay, so we are going to fill in these ordered pairs. So the ordered pair is going to be 1, 0 for the first one, -4, -5, and 17, 17. Okay, if I needed, this is a function because it's on the side of functions. And when I'm going to determine why this is a function, I'm going to look specifically at those x values. Is each x value only used once?
No.
Yes, it is. There's a 1, there's a -4, there's a 17. Each number is used only one time. Therefore, it's a function. Okay? So I'm going to put, this is a function because each x value is only used once. As long as your x value is not used more than once, then it's going to be a function. Okay. So if I look at a non-function, not a function example, okay? If I keep my first two ordered pairs the same, so I have 0 or 1, 0, -4, -5, what could be an ordered pair here? It's going to be something 17. What would I need to make this x value so that this would not be a function?
You have to use 1 or -4.
Correct. So I can either put a 1 here or a -4, and now I don't have a function. Because I just duplicated an x value. And I used 1, so... Okay, so if I'm looking at just ordered pairs, does that make sense why 1 is a function and why 1 is not a function? Okay, so you're only concerned about x values. You don't care about y values. Okay, so if we're looking at a table here, we'll put the value, the first one, I'll go down the column. So x is -1, 1, 2, 3, 5. My y values, I'm going to make all 7s. I'm going to look at my x column there. Is this going to be a function? Well, yes, because it's on the left side of your paper, but why is it a function?
Because
X values?
the x values aren't repeated.
Right. And I'll put that. X values are not repeated. Which is a little different description of what I set up above, but it means the exact same thing. The x values cannot be repeated. Okay? So if we want to take this table and make it not a function, do I have to change any of the y values?
No.
No, so these can all stay 7s. Now, somebody change my x column so that I don't have a function now.
-1, 1, 2, 2, 3. There you go.
Why is it not a function again, Liz?
Because the x value is not repeated.
Because the x value is repeated.
Or
It is a 2.
It is repeated, yeah.
Right. The 2's right here are repeated. So this is not a function because 2 is repeated. And did it have to be the 2 that she chose? No, last block chose 1. They repeated 1 twice. It's any number that's repeated in that x column more than once makes it not a function. Okay, this graph is the most important graph and kind of the most important idea that we're going to talk about on here, because this is the type of graph that we are going to look at for the next 12 weeks. Okay, this is a quadratic. Okay, and so we will be studying graphing them, writing them, stretching them, shrinking them, and some physics applications of them. Okay, so this is a function because Has anybody ever heard of the VLT or know what that stands for? Okay, VLT stands for vertical line test. So if you don't know what it is, we probably should write it out. It's the vertical line test. And what that does is it quickly allows you to look at something to determine whether it is a function or not by looking at vertical lines. So if you take your progress report paper that I gave you before, okay, and we start at the left side of our graph, and we continue across here, and we're using this side of my paper as my vertical line. It's going up and down. When I touch my graph, every time or every vertical line I could draw on my graph would only touch my line how many times? Once. So if a vertical line touches your graph only one time, then it's going to be a function. Everything that we studied, every line that we studied besides a vertical line, and every quadratic that we study will always be a function. Okay? We will not study things that aren't functions until fourth quarter. Okay? Now, that should help you understand why this circle is not a function. If I come across here like this, I draw a vertical line. How many times did I just touch that circle? Twice. Therefore, it's not going to be a function because it doesn't pass VLT. It doesn't pass your vertical line test, therefore it's not going to be a function. Okay? Okay, and the last two, basically this is the same as the first one, except instead of writing out the ordered pairs, I just graphed the points. So you can do it the same way as the vertical line test if you want. If I come across here with vertical lines, I need it to touch each ordered pair only one time. Okay? So you can say, you know, no x values are repeated, or vertical line test allows you to have that as a function. If I look at this one that's not a function, where is the problem area? Why is this not a function? At what value of x is it not a function? Somebody said it, at 1. Right here. If I draw a vertical line, how many dots did I just touch? 2. And you can never touch more than 1. So it doesn't pass VLT. Okay? Now we're going to go back up here to this first ordered pair, these 3 sets of ordered pair that was a function. Let me make sure. Okay? And we are going to learn to state the domain. So what is the domain of this problem? If you're not for sure, on the front it told you your domain was your x value. So what are your x values of this problem? 1, -4, and 17. And all you have to do is write them out when they are in ordered pairs already. So the range is going to be what values? 0, -5, and 17. That's it for domain and range. That's it. Okay. So I'm going to kind of skip. I'm going to go over to this table that was not a function. Okay? And I'm going to list my domain. Your domain are your x values. So if I list my domain, your domain is going to be
Negative one.
-1,
One.
1,
Two.
2,
Three.
3. And so I can actually look at my domain and see why this is not a function, because I wrote 2 twice. It is not incorrect if you only write 2 once also. It takes the answers either way. And then your y would be your range. So what is the range of this problem?
7.
7. That's it. And if you want to, write 7 5 times.
You don't have to.
You don't have to. You can write it only once. Okay? Okay, the most important one, which I already mentioned, was this quadratic here. Okay? All quadratics have the same domain. So memorize this so that when you get to January 20th and you're having a test, and I have no idea what January 20th might be, a weekend. Let's see, I can figure that out. Actually, I think that is. I think it's a Saturday. So let's go with January 23rd. That's not a Saturday. I only know that because my daughter's going to spend 2 weeks in Colorado in January without me. So I know the 17th is a Tuesday, so I know that. The 20th is a Friday? Okay, so the 20th is a Friday. So that could be a test day for us. Okay, so what do the arrows mean on a graph? It keeps going. So this graph is keep going to the left and keep going to the right and up, right? That's what's going on with this quadratic. So my domain, if I keep going to the left, I'm covering all my negative x values. And if I keep going to the right, I'm covering all my positive x values. So I've used all my x values. What's the mathematical saying for using all of something? Yep, there you go. All real numbers. So the domain of every quadratic that I give you has the exact same domain. You're always going to choose all real numbers. That shouldn't be too hard. Now, your range tends to be a little bit harder. And your range, okay, range goes top to bottom. So the lowest number here is 0. And then it's everything up from there. So how do I write from 0 and greater? Greater than or equal to? Okay, and the range is range x or y. So you have to do y is greater than or equal to 0. So your range on a quadratic will be an inequality of some sort. Okay? Range a little bit harder, but still not. Okay, I'm not going to do any more on that side. I think we got those. We're going to move on to your other piece. Here. Okay, so all it's asking you to do here is to state your domain range and tell me if it's a function or not a function. Okay? So if I want my domain, what am I looking for, x's or y's? X's. So I'm going to write down the number 0, 1, 2, and 3. I wrote down my domain. My range is going to be my y values. So can we just copy down those y values? -3, -2, 1, and 6. Okay. Now, is this a function or not a function? Which one am I going to look at, x or y's? X. Is any of these x's repeated? No. So is it or is it not? It is a function, so I can just circle function. Okay, number 2. those dots there. So my domain is going to be my x value. So this would be -3, -2. -2 is twice here. -1, 2, and 3. Those are your x ordered pairs. My range, if I start here, this would be -1 twice. Then I'd have 2 twice, and I would have 3 twice. Is this a function or not a function? Not a function. The treble case is right there. I'll circle it, because those are going to repeat. We'll stop there. We'll let you clean up, and we'll stop there.